Hi everybody, welcome to part 2 of tonight's video. So we're continuing on to talk about law of signs, but in this particular case we're looking at the ambiguous case. So we call it ambiguous because when we're given information about a triangle, we're not sure if it's 0 triangle solution, 1 triangle solution, or 2 triangle solutions. And if you find, for instance, like 2 triangle solutions, you have to solve for 2 different triangles from the information you're given, and both the triangles that you get have to include the information that you're already given. So you just have to find some missing parts in the 2 triangles. So let's get right into it. I created kind of a cheat sheet for you guys because sometimes it can be hard to determine how do I know if it's just 1 triangle, 2 triangles, or 0 triangle solutions. So if you're given information, so make sure that you're labeling counterclockwise. So you begin at A and then label your triangle counterclockwise. So I began A, B, and then C. And what you want to do is find a height. Normally the height is not provided, so you have to use your SOHCAHTOA to find the height. And after you have that, now you just need to do some comparisons, just like they mentioned in the previous video. So what you want to use as your reference length is the opposite side, and I call it the opposite side because it's opposite from this reference angle called angle A, or theta in this case. So if that opposite angle's length is in between the height and the adjacent, then you have 2 triangles. And if that opposite side length is the shortest, then you have 0 triangles. But if that opposite length is the same as the height that you get over here, then you have a right triangle. And last but not least, if that opposite side length is greater than both the height and the adjacent, then you end up with just having to solve for 1 triangle solution. So let's put that into examples. This is the first example here. We're given that the side length A is 15, side length B is 25, and the angle A is 85 degrees. So we also want to make sure that we're being very keen on notation, because we use uppercase for the angles and then lowercase for the opposite side length. So for instance here, I've got my angle A is 85, and they told me that side A is 15. So opposite from 85, I put my 15 units on this length. So the strategy is that I label my triangle. After I'm given the information, first thing I need to do is sketch a triangle. So I sketch the triangle. It's not up to proportions. So after that, I need to label it counterclockwise, same way that we read a unit circle. So it goes A, B, and then C. And then I noticed that once I sketch the triangle and put all the information I was given in it, it comes out to the side angle congruency, which tells us that this is an ambiguous case. So we have ambiguous case because we have to figure out if it's 0, 1, or 2 solutions of triangles. So I noticed that that is for side angle, that is the side, that is the next side, and that's the angle. That's why side angle. So to determine the height, I just use SOHCAHTOA. So sine of 85 degrees is the opposite over hypotenuse. And once I drop this perpendicular, that becomes my opposite side. And that's what I'm really trying to find. So after I set this up, all I need to do is multiply both sides by 25. So if I multiply the right side and the left side by 25, I can reduce that to get a height of 24.90. The next thing I need to do is compare. And remember, my reference length is the opposite length from the angle that was given. So I have 3 lengths. I'm just going to put them on a number line just so it's easier for me to see. I have 15, and then I got 24.90, and then 25. I just put them on a number line, and then I circled my reference angle. I noticed that my reference angle is the smallest in this case. So if I don't quite remember if this means 1, 0, or 2 solutions, I can go back here to my cheat sheet and check out. Okay, so I found that the opposite length was the shortest. Oh, that's the second case. So if I have that opposite side as the shortest, then I have 0 triangle solutions. Looks like I'm done solving that one. And you can see that's what I wrote down to the bottom right there. All right, so how about this second case here? You're given 42 degrees for A, 12 units for B, and 22 units for A. First off, you need to sketch. You need to label your triangle counterclockwise ABC, and then you need to input all the information you're given. The 42 degrees, the 12 degrees, the 12 units, which is B, that will be across from angle B, and then 22 units, which is across from angle A. So I input all that. Next, I need to find my height because I'm going to be using that pretty soon. So I drop my perpendicular and then sine of 42 degrees. I determined that my height is 8.03. Honestly, at this point, it doesn't mean much to me. So I draw my number line, I plot my 3 points, and then I notice that since 8, so 8 comes first, and then 12, and then 22. And again, what is my reference length? My reference length is the opposite length. So I just kind of circle it. And now is when I ask myself, okay, so what was the case if my reference length was the longest? If I don't remember, I can go back to my cheat sheet. And I noticed that the last option says the opposite side is the greatest out of everything. That means I've got a one triangle solution. Okay, that will be easy. So I come back, I label all my angles, all my sides. I input what I was already given in black, and I'm trying to find the pink. So my work is at the bottom here. At first, I use law of sines with this is the known because I was given both an angle of A and a side length of 22, which is opposite from the angle. So I set up the known, and then I set up the unknown here, which is I already have side length B, but I don't have angle B. So setting this up will enable me to find angle B. And then what I need to do here is simplify. You can cross multiply. And then 12 times sine of 42 equals 22 times sine of B. And then what happens after is you need to take the inverse sine of B to get B, which is 21.41 degrees. If you have trouble with this part, you can come see me. And then, so right now, that gives me angle B. I can input that right there. So for angle C, what do I need to do? Well, what does the triangle sum theorem tell me? It tells me that the angles in the triangle add up to 180. So I already have two triangles, A and B. In order to find C, I'm just going to take away those from 180, and I get that that's 116.59, and I input that right there. And it looks like the only thing I'm left with at this point is the side length C. And at the bottom, I set up my law of sines ratios again to help me find side length C. And I use the known, which is sine 42, divided by side length of 22, which is opposite from it, equals the sine of C, which I now know what angle C is, which is 116.59, divided by side length C. And then I simplify that by cross multiplying and then isolating for C, and I find that side length C is 29.40 degrees. So I have all the units for that one triangle, and in this case I just needed to find solutions for one triangle. I am done. All right, and then the last case, which I cannot find, so excuse me just a minute. Righty. So for this one, I'm given A, B, and C. I mean A, B, and A. That means two side lengths because they're in lowercase, and one angle, 20.5. First off, I go ahead and sketch a diagram. You can see here I put my notes as I sketched, and I sketch the triangle, and then I do counterclockwise labeling A, B, and C. I input all the information I'm given. Next up, I need to find my height, and I use SOHCAHTOA again. So sine of 20.5 equals opposite, which is this perpendicular height over the hypotenuse, which is 31, and I find that my height is 10.86. You can check my work by trying this example on your own and comparing the answers that you get. At this point, I'm ready to start comparing the three heights because I have that height, and that height. So I put my number line and then I just kind of insert them. I have my height as 10.86, and then I have the opposite as 12, and then the adjacent to the angle A as 31. And what's my reference angle? That's the question you need to ask yourself. My reference angle is the side opposite from the reference angle, which is 12. So I go ahead and circle 12, and Remember from our cheat sheet, what is it, what's the solution if our reference angle is in between? Well, I can go back and I noticed that, oh, it's the first option there. So if the opposite is in between the two lengths, then I have two triangle solutions. So it looks like I'll be solving for two triangles. So that's why I divided my work in the first section up here, and then in the bottom section is the next solution. So I go ahead and just do the steps as the previous case. I put my A, B, and C, A, B, and C. I put what I know in a black pen, which means I need to find the others, which are in pink. I input law of sines, with the left side is what is known or given to me. And then the right side is sine of B over side length B. Side length B was already given as 31 meters. I solve that and I find that angle B is 64.78. If you do not know how to take the inverse sine, please make sure to ask me. At this point, I have two angles. In order to find the third angle, I'll use the triangle sum theorem, which tells me 180 minus the sum of the other two angles in the triangle gives me the third angle. In this case, angle C will be 94.72. I go ahead and input that. And then I was already given two side lengths. I just need to find the third. And in order to do that, I'll just utilize law of sines again, using what I was already given. And then the angle of C, which I've determined from this case, is 94.72. And that's what I put right there. Divide by side length C. I go ahead and solve this by cross multiplying. You can see I said cross multiply. And then to isolate for C, I just divide both sides by sine of 20.5. And I get that side length C is 34.15. So I'm done with the first case. How about the second case? Well, in the second case, I know that I'm gonna have to use the same information. The angle A, side length A, and side length B, those have to be part of my solution. So what I need to do is I sketch the whole thing, and I've already found the solution when it's this whole triangle. So I'm gonna drop a side length of 12 here. This is like if you swing the 12 back, and this will end up giving me what is called an isosceles triangle, and that isosceles triangle tells me that the bases are really the same. So from the previous case, I already know that angle B is 64.78. These are isosceles triangles, which means this base will also be 64.78. Now I put the triangle that we're trying to solve for in case 2 here so that we could isolate it in the next step. So in order to find that base triangle there, these are angles on a straight line which add up to 180. So I can use my linear pair theorem, which gives me 180 minus 64.78 to give me this angle B, which is 115 in this case, 0.22. That's what I got from my calculator. So I've got angle A, angle B, and in order to get angle C, I'm going to use my triangle sum theorem. You can see me subtracting the sum of the two from 180, and I get that angle C is 100. No, it's not 115. That's a typo. It's 40. What did you guys get from your calculators? It's 44.28. You can see in the bottom left there. So I've got my 3 triangles, and then I had 2 side lengths. So at this point, I just need to utilize law of sines one more time to get the last side length. So I use what I already know. Sine of 20.5 over the opposite, which is 12, equals sine of 44.28. And now I'm trying to find this side length. That's why I'm using that angle 44.28 divided by the side length C. I cross multiply and simplify to isolate for C, and I get that the side length C is 23.92. So at this point, I've solved for my 2 triangles, and my answers are kind of like in the bottom of the triangles there. If you have any questions, let me know.